BackboneFast is a spanning tree protocol feature that speeds up convergence times due to indirect link failures. In our topology here, DSW3 is the root bridge, so it has a designated port. This will be a root port. This one will be a root port. This will be designated. This will be designated. This will be a root port. And this is our blocked port within the topology. So from DSW2's perspective, an indirect failure would be a link that is not directly connected to DSW2. So let's say that this link right here fails within the topology. When this link fails within the topology, DSW2 has no idea that that failure has occurred. However, DSW1 is now no longer receiving what? It's no longer receiving the BPDUs from the root bridge. And as a result, DSW2 will not receive those original BPDUs inbound on this interface about who the root bridge is. Therefore, this port, which is currently in the blocking state, will have to transition at some point. But because it's an indirect failure, the timer, that max age timer, has to expire first, 20 seconds. And then the port will have to go through the listening state and the learning states for a grand total of what? How long? 50 seconds in total, because this link over here has failed, that indirect link, according to DSW2. On top of that, DSW1 now thinks it's the root bridge for the spanning tree topology, so it's going to send out bridge protocol data units, BPDUs, indicating that it is the root bridge. However, DSW2 receives those BPDUs and says, well, wait a second. My original BPDU on this interface came from a completely different device with a completely different bridge ID. Your information is not the same. Therefore, I must wait for all of my timers to expire. Max age timer, and then go through the listening state and the learning state. Well, with BackboneFast, we can speed up this process by eliminating that max age timer. So instead of having to wait the 20 seconds for the max age timer to expire, when we stop receiving those BPDUs from the original root bridge and we start receiving these other BPDUs from DSW1 claiming it to be the root bridge, with BackboneFast enabled, our switch DSW2 can send out a query. It can send out a query, and this is known as a root link query. And that root link query is going to be forwarded on through the topology. What this root link query is about is trying to find out if that current root bridge that we know about still exists. And if it does, well, then we could transition this port here to the forwarding state, make it a designated port, and then have this end up becoming a root port, and this port no longer exists because the link is down. So that's what can happen. But the thing is that the switch DSW2 who sent the root link query is waiting for a reply from the root bridge. So if it doesn't receive a reply from the root bridge, then there's a problem. But if it does receive a reply from the root bridge, then everything is fine. And then DSW1 can be informed that this is the best path to get back to that original root bridge. So it's a very important feature when we are using spanning tree protocol and we want to get rid of that max age timer that has to count down when there is an indirect failure. So where do we enable this feature? We have to enable it on every single switch in the topology. And why is that? Because only those switches that are running BackboneFast understands those queries and replies that are being sent, the root link query and the root link reply. They're the only ones that understand it. So if you don't have BackboneFast on all of the devices in the topology, then this process is not going to work. So you enable it globally with the spanning tree BackboneFast global configuration command. And if you want to verify the state of BackboneFast, you can use the show spanning tree BackboneFast command. And we don't need it for rapid spanning tree protocol. Why? Because it's already built into rapid spanning tree protocol. So in our live environment, if we wanted to enable BackboneFast, we would have to do it on all switches with the spanning tree BackboneFast command. Let's do that. Configure terminal, spanning tree BackboneFast. ASW2, configure terminal, spanning tree BackboneFast. DSW1, configure terminal, spanning tree BackboneFast. And lastly, we'll do the same thing to DSW2, spanning tree BackboneFast. If we go back to ASW1, we type in show spanning tree BackboneFast. We can see that spanning tree BackboneFast is enabled, but nothing has happened right now. There's been no transitions because of BackboneFast or using BackboneFast. No inferior BPDUs have been received, and we haven't had to send any root link queries or root link or receive any root link replies in this particular case. But if we did have any transitions that required the use of BackboneFast, we would be able to see the statistics here.